Here we have a Howe truss, and it has three external forces. First one at H of 475, at J of 200, at K of 375. We are asked to determine the reactions in the members BC, CJ, and JK, their magnitudes, and whether they're in tension or compression. The first step we're going to do is we're going to determine the reactionary forces at A and G. By observation, A sub x is 0, so we don't have to contend with that because there are no other forces in the x. We'll use the summation of moments at A to determine G, and we get 375 pounds in the upper direction. Summation of the forces in Y yields A of 725 pounds. Now we got to look at the section and what side that we're going to pick. I am going to choose the right side in this case, even though it's the longer section. It has less forces on it, and also if you look at when we're cutting this section, only one member BC is at an angle. So let's go and pause the video and draw that. Alright, so here we've got the free body diagram with that section drawn, and we've identified our reactionary forces, 375 at G, the applied load 475, and also indicated the unknowns, BC, CJ, and JK, indicating them all in tension initially, so that as a matter of convenience, and if we get a negative number, we just reverse that to compression. So I've also thrown down some dimensions there. So the height of the total truss is 12, and each panel is 6. But you note that I'm also solving for additional distances, such as between E and L. I've labeled as Y1, which is also the distance between C and J. I also indicate several of the joints that are off on to the left that aren't part of this. And also from the distance B to H. Now I'm doing this because it helps when I am calculating my moments, and I'll need those. So using similar triangles, I have determined Y1 to be 8 feet and Y2 to be 4 feet. I then will use the summation of moments at C. Okay, I do this because it eliminates two of my unknowns right away, BC and CJ, and I can solve directly for JK. Putting in all the numbers there, and I get a force magnitude of 768.8 pounds. It's positive, therefore it guessed correctly and is in tension. I then move on to the summation of moments at B in this case. And when I do B, which is off the truss, that allows me to isolate on CJ. Okay, and you can do a different approach. I'm just going to do a bunch of them. And I lay out all the forces and the moments created by them, and I get CJ of 412.5 pounds, and it's in tension. So I guess correctly on that. I then can move on to the summation of the forces in the x direction, and I can solve directly for force BC. In this case, I'm showing and using the component for that force of BC, which is the magnitude of the total force BC, times 3 divided by square root of 13. Okay, that will give me my x component, because if you look, that truss, that member is aligned with the triangle which has 2, 3, and the hypotenuse is square root of 13. But you'll notice that I get a negative number, so I just change it to 924, which is the magnitude, and just indicate positive. Okay, so that's actually a negative number there, but I'm just reporting it as 924 pounds at compression. Next, I move on to the summation of forces in the Y as a check. You could even jump right to here as well, and I get 0.04, plugging in all the numbers I came up with, and that's close enough, especially since we're really reporting closest to the pound. And if I were to use carry over more digits, that would be even closer and closer to 0. Summation of moment about J, which is where I could have started as well. Or excuse me, a summation of moments about J. And if you notice that I could have started there, as opposed to the summation of moments about C, because JK and CK drop out, leaving me only with BC, so I can solve directly for BC. I'm using it as a check in this case, and I get minus 0.1 or 0.516, close enough to 0. It's a check. Again, if I were to carry those decimals out further, get a little more accurate, that number would drop closer and closer to 0.